Hello everyone, welcome to my channel. So today we are going to do Leetcode weekly challenge, the employee that worked on the longest task. So this was the first question of today's weekly challenge, and as you can see, this is the easy level question. So the way they have written like that way exactly we are required to do this question means there won't be any sort of tweak in this question means the way it is written, so out of the box we would be required to think or something like that. That won't be the scenario here. Here only thing would be that we will be required to do as it is the way it is written. So before starting with this question, let me tell you about one more thing because you are doing LeetCode daily challenges, LeetCode weekly and my weekly contest. So I want to tell you about one more contest. Basically, Newton School is coming up with their own coding challenges, and for that purpose you could head over to the description below, and there you could figure out that link and you can register for the same, and registration is completely free of cost. And the best part of that is that you would be practicing from there also, and the thing is whenever you are able to reach the high performer, then you will be able to get exciting prizes for the same. So that would be one of the plus point, right? Means the thing is that whenever we do a particular contest and when we get a prize out of that, being a top performer, then surely that boosts our confidence as well, right? So that's why, as it is completely free of cost, you could directly head over to that link and just to complete the registration, and surely it would be beneficial for you, right? So you can do the same. And now let us concentrate on this particular question. So basically, let us first read this question and then the constraint of the question, and then I'll let you know that how to build up the intuition, and then we will be doing the code. So this is all. So there are n employees, each with the unique ID from 0 to n minus 1. You are given a 2D integer array logs where log of I. So it is a 2D integer array. So it would be having like means its structure would be 1 minute. Uh, Basically, my alignment of the pen is somehow good, so I just need to make it correct. 1 minute for the same. And sorry for inconvenience also. Yeah. So, yeah, now I can do. So here the thing is that see, so as we are saying that it is a 2D data structure, right? So the things would be something like this, right? Here it would be having IDs, and here it would be having the time which is being required, right? So two components would be there. So this is what they are saying, that first would be ID and the other one would be leave time, where our IDI is the ID of the employee that worked on our task. So basically there would be n number of tasks, and corresponding to that there would be n number of IDs and time taken for that particular employee. That would be the thing which is given to us in this particular logs. And the leave time is the time at which employee finished our task. A value leave time are unique. So this is the thing. Now regarding leave time, we need some more information, and that they have given in this. And according to that, we will be returning our answer. So note that I task starts the movement right after I minus one task. So whenever the previous task finishes up, then just after that only our I task starts, and then the zero task starts at the time zero. So basically our tasks are going with this timeline I, and then our other I plus one task, and then our I plus two task. Basically, this is some X, Y, Z timing. These are the things. So without any pause, our every task would be starting as a previous task did. So that's we want to indicate in the same. Then now comes the next thing, that what exactly we are required to do is return the ID of the employees that work the task with the longest time. If there is a tie between two or more employees, return the smallest ID among them. So this is the thing which we are required to do. That if there is tie between any two timings, then we will be checking that out of those two timings, which particular employee has the smallest ID. and that we will be returning as an answer. Else, in the other case, when there is no time, we would be returning that ID of employee that worked the task with the longest time. And the thing is, here the timing which is being given to us, here 3 is given. So the timings for work would for this particular would be 5 minus 3, and timing for work for this would be 9 minus 5, and timing for work for this would be 15 minus 9. So this is how we will be able to get that how much timing that particular employee had taken. Because these timings which are there, these timings are from 0 to 5, then 0 to 9, and 0 to 15. But the thing is that other person will start only when the previous person has completed the task. So in that context only, we are required to subtract the previous person's time as well. So then only we will be able to get that what was the exactly time of the new person. So this was all in this particular. Now comes the part that how we will be going to do this question. So basically, in this question, what we are required to return is the smallest ID which has the longest time and the longest leaving time, and that we will be predicting by this particular that log of I means whatever at whatever row it is there, I minus 1, and log of I, these are the rows. And now comes the part for the timing. So timing will be stored at this particular, right? So this is the thing, is whatever maximum we will be getting for this, that is we are required to return corresponding to that ith employee. So this is the thing which we will be doing. So now let me show you for first up, let us think about the take about the constraints. So constraints are pretty much lower, right? So as the constraints are pretty much lower, so even a brute force will work here. But here we can effectively go ahead with our order of n solution as well. So here now let us see that how we can do this particular question. The thing is, I'll explain you while doing this code as well. The way I had earlier explained you that what we are required is the smallest ID log I0, because our ID is basically stored at the first part of the that particular vector, right? And which has the maximum this particular thing. That is the difference between the previous one and the present one. So how and why we are taking that difference, that also I have explained, because the timing which is being given to us, that is from 0 till now, and we just required only this portion of timing, not this portion of timing. So in that context only we are doing the difference. So now comes the next part, that first for the result part, because we are storing the we are required to return the ID, so we have directly initialized with this, and the maximum timing which we will be taking, that also we have initialized with the first one. This is just initializing, this is not a final answer. Now this is the thing which we are required to do for our final answer. So basically in our question what we had written, we there it was written that we are required to return first thing is the maximum, right? But if there is tie, then we will be returning the smaller one, right? So this is for that maximum part, and this is for when both of them are equal. So here we can check that if our log of if log of I and log of I minus log of I minus 1, if that is greater than our maximum, means greater than whatever we had initialized earlier, or whatever it would be with the flow, then we will be updating our result, because if our present difference is greater, so corresponding to that our ID would be updated and our max would be again updated, so that we can check in future that if something else come up, else if uh, if this particular is equal to maximum, right? And our result, basically this ID which was there, it is greater than our present ID, and because we require the smallest ID, right? So that's why we will be updating our result, but although that maximum would remain same only because it is already equal, right? So this is the thing, and at the end we will be returning our result. So this is the thing which we are required to do. So for better explanation, let me dry run. Uh, yeah, it would be better that I dry run also. Hmm. So then, so here the thing is, see, here the thing is like first are this particular result and max. So first the result wanna be equal to 0 and our max wanna be equal to 3, right? Now when we enter this particular loop, then in that particular scenario, the first thing would be we will be checking this particular thing. So when we will be checking this particular thing, so we are at 5 and 3, right? So 5 minus 3 is basically 2, right? So 2 is basically less than max because our max is 3. So that's why we won't enter this particular. But when we check that are they equal, then also they are not equal. So again, we will be not entering. So that for because of that purpose only, now we'll be moving ahead. So now when we move ahead and when we go to this 9, so now we will be first checking that what is our 9 minus 5. So our 9 minus 5 is basically 4, right? So 4 is greater than our max, right? So in this context, our result will now become equal to log of I0. That is what is corresponding to this. It is 0. So now it will be 0 and then max as it was 4. So it will be updated to this. So this is the thing which we will be doing. So now this particular has been done. Now it comes to this particular part. So when it comes to this particular part, so now it is 15 and 9. And if we subtract 15 and 9, so it will be, I guess, 6. Yeah, it will be 6, right? So now 6 is basically greater than our max, right? Because our max was 4. So now in this context, our result will become equal to 1 and our max will become equal to 6. And now we have reached the end of our array. So we will be returning our result. So this was the case when we hadn't encountered any equality. It was a straight go forward case. Now let us take example for some other where it is not a go forward case. It is having some equality. Don't know if it would be having equality or not. But let us check. So for this particular case, again, the things would be like this. So our result wanna be equal to 1, max wanna be equal to 1, right? So this is starting and now we will be checking for the next one. So we will be checking that what is our 7 minus 1 to 7 minus 1 is 6. So which is basically greater than our max, right? So our max will be updated to 6 and our result will be updated to 3. So now we will be checking for 12. So 12 minus 7 would be 5. So 5 is basically less than 6. So that's why we won't be updating. So now we go to 17. 17 minus 12, that would be 765. That will be 5. Max is still 6, right? So our result would be directly 6. Let us check. Have I taken same thing or not? Yeah, 3. So our result would be 3. So like this only, we will be able to do this particular question. And this was all for the same. So the basic idea behind this question was just to figure out the smallest ID with the maximum difference of, or you can directly say with the maximum leaving time. And the maximum leaving time could be calculated by difference of the just immediate previous and present time. And why we are doing so? Just for the fact because all these timings are basically from 0, not from that, and they are not from that timing when our previous task just ended. And if it would have been from that, then we could have directly taken these things only. But we can't because it is already mentioned here that how these tasks are being like. So yeah, this was all for this particular question. I In the next video, let's meet for the second question. So yeah, this was all. If you really like this explanation, please do like and subscribe to my channel. And yeah, this was all. Thank you.